Okay, so my name is Svetlana Isakova. I'm a technical evangelist from JetBrains, and today I'm going to talk about Kotlin. Before, I'd been writing the code to the Kotlin compiler, but now I'm more interested in giving talks and writing the book about Kotlin. So let's start. This is our agenda for today. These three buzzwords: modern, pragmatic, and Android-friendly. And it turns out that all these buzzwords mean something important in terms of Kotlin. And we'll see why. Nowadays, any Java 8 language can come up to us and say, hey, I'm modern. But you will look at it and think, not really. But we'll leave this word modern for the dessert. Let's start with more pragmatic issues. So Kotlin is from JetBrains. JetBrains is the creator of IntelliJ IDE and some other IDE that you are, I suppose, aware about. And as it's from JetBrains, you can expect really good tooling support for the language. And that's the case. You have whatever you used to have for Java language, like refactorings, inspections, completion, whatever, you have the same for Kotlin. Another thing that is important and describes Kotlin as a very pragmatic language is that it can be very easily mixed with Java code. So Kotlin language is compiled to class files, to Java class files. And after that, these class files can be compiled to Android format. And that means you can easily mix Java code and Kotlin code in your project. And as for any JVM language, you can, without any problem, call Java code from Kotlin code. But for Kotlin, it works in the other direction as well. And that's not usually just works. It's because a lot of efforts were directed especially to this thing, to be able to very easily mix Kotlin code and Java code in your project. Another important aspect is that Kotlin now is very Android-friendly. At first, as you know, Android Studio is based on IntelliJ. That means you have all this tooling for free. It just works in Android Studio. We do not have to do anything special for that. It just works. Another thing, important thing, is that if you add Kotlin to your application, it's just another library. It waits just as another library. It is, so comparing to some other JVM languages, it's much easier to add Kotlin to your project. Why it is so? Why do we have so small library? Actually, there is an explanation for that. One of the explanations. In Kotlin, we do not have Kotlin SDK. We use Java SDK, Java standard library, and a bunch of extensions to that. So we do not reinvent anything. We do not create our own libraries, collections, and so on. We use standard library. And because of that, you at first have this small runtime jar, and this small method count, and methods count number, and what's more, we want to even decrease this number later. So at first you have so small runtime jar, and secondly, you have very easy interop with existing Java code. Because you do not have another collections, you do not have to convert every time to wrap, etc. It's very easy to mix. Okay, so now it was some kind of introduction. And then we have this word modern. And the rest of the talk, in the rest of the talk, I will show you examples of what benefits you can have. Kotlin is more concise than Java. It's safer than Java. And it is more expressive than Java. So in this sense, we try to compare it with what we have and what we used to have. OK, so the first thing, Kotlin is a concise language. OK, I'll show you actually one example of that. You see here, what's that? Of course, at first, yes, it's Java, for sure. And it's a standard Java data class. It does nothing, it just stores the data. And now I'm going to show you one trick. The trick that the tool that that is a great tool if you start adding Kotlin to your project, and at first you want to learn a new language, and maybe you do not remember how to express something in Kotlin. You can use this automatic Java to Kotlin converter, and it will convert the Java code to Kotlin code for you. And it's the best at first when you learn the language, and then when you slowly add some new Kotlin code to your project, you can convert the existing code gradually. If you want, you do not have to rush at all. At first, you should try and see. So we have this after the conversion. And an important thing is that it's not exclusive for the Kotlin language. So if you look at Scala, if you look at Ceylon, if you look at Swift, Groovy, etc., if you look at all those modern languages, they all have the same thing. So it's like nowadays we know how to express things better, how to express patterns that we used to have like very often, almost every day, in a more concise manner. And what's more, in Kotlin, you can add one modifier, one data modifier, and this data modifier will generate a bunch of useful methods for your class. So when you declare a data class, you often want to be able to compare the instances of this class not by reference comparisons, but by value. And that's what this data modifier means. It will generate u equals hash count and just nice to string and some other methods. And again, this is not exclusive for Kotlin, and it is not only a feature that makes Kotlin concise. So there are many of them. And for example, there will be another talk by Machi, the talk after mine, and I hope he will cover much more features of Kotlin that make it concise. OK, but now we're moving to another thing that makes Kotlin modern language. It's safe. OK, let's look at the example. Very often, we know this problem. Some error has occurred. And on Android, it looks like your app has crashed. We don't know why. Sorry for that. OK, so it suggests that we can see the details. Yeah, the details. Very informative. Thank you. Thank you, compiler. Now pointer exception somewhere. And this is word by Sir Tony Harvard called the $1 billion mistake, because we just can't count how many money we spent on fixing it. This $1 billion mistake, he calls it his invention of nullable reference. So the problem is that the reference can be null, and we cannot know where it's null or not, and it fails at runtime, and all the users suffer, and that's no good. OK, so, and now there is a modern approach. Again, it's not exclusive for Kotlin, but Kotlin does that. To make such error a compile time error, not the runtime error. And different languages solve this problem differently. So I will show you Kotlin way to solve this, nullable types, And it is the same as in Swift language. But for example, if you know about Scala's approach or an approach of Java 8, it will be different. So what's Scala approach? Does anybody know? Or Java 8 approach? What do we do in Java 8? Yes, it's option types. And later I will a bit compare it with Kotlin approach. So, but in Kotlin, it's not option types, it's nullable types. So when you declare a variable in Kotlin, you can declare it as a usual variable, like string. And in this case, it differs from Java. It can contain only not null objects. So the value of string type cannot contain null. And if you want it to be able to contain null reference, you should declare it explicitly with a question mark. So type with question mark means, OK, the value of this type can contain null. And you can safely dereference the first variable for sure. So there are guarantees from the compiler that, yes, you can do that. You won't have this null pointer exception later. But if you try to dereference the nullable variable, the value of the nullable variable, the compiler forbids that, because it's dangerous. So you have to check explicitly whether you can do that or not. And Kotlin gives you several ways how to do that. At first, as in Java, you can check that explicitly. So if you can check that whether your reference is null or not, and if not, dereference your variable. There is the first case, but it's a bit of a burst, yeah? It's like Java. And actually, in Kotlin, you can do better. You can say, yes, a variable, then question mark, then dot, and then what you want to do. And it is called safe access. If I'm not mistaken, this feature was stolen. It wasn't invented in Kotlin. It was, to some extent, was stolen from Groovy. And there it turns out it's to be quite useful. So what does it mean? If the value in this variable is null, then return null as a result. If it's not, return what's expected, the length of a string. OK. And the result type will be nullable type. The result will have the nullable type, because it can contain null for sure. OK, if you want to provide the default value for the case, you can use so-called Elvis operator, and that will mean if it's null, if the expression is null, return 0 as a result. So you see there are quite a few ways how to deal with nullable types, and there are more. So you can check explicitly if the reference is null, and then if it's null, for example, fail or return, it's a very regular pattern in Java code. And after that, the compiler allows you to dereference this value. And of course, you can dereference it explicitly. You can say, throw null pointer exception if it's null. And this nullable types feature, it's very similar to the Swift language. If someone knows Swift, it's very, you recognize this feature. And in Swift, they use one exclamation mark to say that throw null pointer exception if it's null. In Kotlin, we use two, just to, please do not use these two exclamation marks. If it's for rare cases, you have it, you can use it, but try to avoid, try to use safer ways. OK, then an interesting question, and to some extent, a way to compare this feature to option types in Java 8. Nullable types under the hood do not add any performance overhead. Why? Because they are implemented through annotations. So when you declare a variable of nullable type and a variable of non-nullable type at runtime, they will be just variables of these types. There will be no wrapper as for option types. So there is no overhead. So these types exist during the compilation phase. The compiler checks everything, ensure that you do everything OK. But then there is this information no longer is stored on the runtime. So it's stored, but it doesn't add any overhead. That's important. Okay, maybe do you have any questions on the features we covered already? Okay, then we'll move on and look at the last thing that describes Kotlin as a modern language, this expressive buzzword. What do we mean when we say the language is expressive? For me, it means that it gives you more power. It allows you to do more things. It allows you to write nicer code at the end. It lets you avoid duplication and gives you the tools to make the code look nicer. So it's very, to some extent, it's a philosophical issue and not very easy, but I'll show you some examples. How, for example, Kotlin expressiveness allows you to avoid duplication in some places. Okay, and I will cover 3 features, and this is my agenda for the rest of the talk. Oh, we have plenty of time. Great. The first feature is extension functions. Let's check. Who thinks he understands what are extension functions already? Okay, some of you. The second one is lambdas. Who knows about lambdas? I think most of you. Great. And the last thing is inclusive for Kotlin. It's I do not know now other languages that provide you the same feature. It's lambdas with the receivers. I would say it's the most advanced feature in Kotlin, and we'll cover it in a few minutes. So let's start. Let's start with extension functions. Again, it's not the feature invented in Kotlin. If I'm not mistaken, the C# language has the same feature, so that's why some of you might have known it. What does it allow us to do? We can declare a function as an extension to a class. For example, in this case, I would say every project has its own string utils or some other util, so you use some special library class for that. And how do we implement it? We usually provide a bunch of static functions in a special class that you can use. Kotlin gives you another way to do that. You can declare this function as an extension function, and in the body of this function, you will use this as a reference to receiver. So this will be string in the body of this function. And as usual for this reference, it can be emitted. So you have this simple code. OK, what can you do with extension function? The most interesting thing is that you can call it after the dot as it were a member. So it looks like it's a member, and you can find it in completion. So you don't have to go to this util class full of static methods. You just invoke the completion, choose the right function, use it. That's all. That's much easier. And important thing as well, that to use this function, you have to import it explicitly. So this feature doesn't make your code very dirty when you can't understand what's going on, where this function comes from, and so on. So to be able to use it, you import it. You can import it by star, import everything in this package, but it's explicit. So we do not allow to use them everywhere in the project. Before I told you, I have a question for you to think of it while I'm talking. What do you think? Is it able to call private methods of string in the extension function? Yes or no? Very easy. So I will continue talking, and then we'll return to this function, whether it is possible to call private methods from the body of the extension function. So please try to guess what's the right answer. OK, so let's continue our discussion and look how we call such functions from the Java code. As I told you already, Kotlin can be very, very easily mixed with Java code. That means that you can easily invoke all the Kotlin functions from Java code. And that's how we do it. Actually, under the hood, this extension function is compiled to a regular static function in Java that takes the receiver as a first parameter. That's it. No mystery here. Very clear. And from Java, you use it as a regular extension function, providing the receiver the first argument. And again, in Java, you can use static import and make your code look easier. So returning to my question, what do you think? Is it possible to call private methods of the string class from the extension function in Kotlin? Who thinks yes, it's possible? Some. OK, not many. Who thinks it's not possible? Why? Yes, it's the right answer. That's because it's compiled to a regular static function. You can't call members of the class from a static function in Java. You can call members of the class only inside this class. So that means Kotlin does not provide you a tool to change the class at any way. No, we can't change the Java standard library, the Java standard string class. But we can provide you a nice tool to use it in a more nice manner. OK, now I'm going to show you more Android-specific examples that use this extension functions feature. So this code, what it does, it shows toast, yeah, nothing intriguing. And in Kotlin, you can express the same concept easier. You can just write, OK, you can just call the function toast and provide an argument, a string that you can show. OK, why it is possible to declare such a function? Because you see, this, in the example above, is an activity. And in Kotlin, we can emit this if we call an extension function on it. So in Kotlin, in the library for the Android, we declare a function called toast that is an extension function to an activity. Then you can call in your code, and it will look just like this, without this extra verbosity, extra information. And that, again, that makes the Kotlin code overall much more concise compared to what you have before. Another example, very similar to the previous one, but a bit different. So this is the way to call the activity, providing the parameters for the intention. OK, and in Kotlin, you can write you can call an extension function, start activity, with the parameters what activity should be started, and what parameters do you need to pass to the intention. And you can emit this, and again, this code just looks more concise. And if you repeat this code often, it overall decreases the size of your application.